The last video. Here we are, 59. Determine the number of terms in n in the arithmetic series. Again, you need to know how to find n this time, but you're still talking about a series, so I wrote the formula over here again. So you're going to say if s sub n is 748, n is what you don't know, a1 is 18, an is 118, and divide by 2. This would become 748 equals this right here, using your calculator, is 68n, so n is 11. Determine if the sequence is geometric. So it is, because it multiplies by 3 every time. This is the formula you use to find the explicit. So a sub 1 is -3. The ratio is times 3 to the n minus 1. That's the explicit formula right there. Now to find the 8th term, you just plug an 8 in. So -3 times 3 to the 8 minus 1, and let your calculator do that work. -6561. This one, determine the number of terms n in each geometric series. Again, we're trying to find n. This can be a little complicated, but they told you s sub n is -124. They told you a1 was -4. 1. Now you need to be careful right here. When you minus, you're not minusing the -6 and changing it to a positive, because -6 is going to a power of n. So it's minus a -6 to the n. You can't change that sign right there. You have to, remember, order of operations says exponents first. You can't touch that. Over 1 minus r. Now that one you can change. 1 minus r -6. So this becomes 7. And you can multiply that 7 over here. So -124 times 7 is -868. Equals -4 times 1 minus -6 to the n. And now I want to divide out that -4. 217. Equals 1 minus -6 to the n. Now I'm going to subtract that 1 over, and that's going to be 216 negative -6 to the n, and that's really a -1, so I'm going to divide that over to be -216 equals -6 to the n. And now I can finally think of what -6 to what power gives me -216, and you can figure it out with logs or anything, but honestly, if you just kind of plug in a few numbers, it comes right away. But the cube is -216, so n must have been 3 terms. All right, expand. This is using binomial expansion. You really only have to go to the 5th row. So if we're doing this right here, we look at the 4th row of Pascal's triangle. So that's 1, 4, 6, 4, 1. And then I just start with the first term, v to the 4th, and then just work my way down, v3, v squared, v1. You can write v0. And then 4, the second term, 4 to the 4th, goes this way. 4 to the 4th. 4 to the 3rd, 4 squared, 4, and then you can write 4 to the 0. And then just clean it up. So this would be v to the 4th plus 4 times 4 is 16v cubed. This is 16 times 6, which is 96v squared. And then this is 4 cubed. 64 times 4 is 256v. And 4 to the 4th is 256. And we'll do that with 2 terms. This is going to a 3 power. So we would write 1, 3, 3, 1. And so we would have 4n to the 3rd, 4n squared, 4n to the 1, and 4n to the 0, and then we're going to work backwards. We're going to have m, and it's negative m, so you either have to remember to change signs or you can include it. I might just include it here. So negative m to the third, negative m squared, negative m to the first, and then negative m. And then clean up each one of these terms. So 4 cubed is 64n cubed. 4 squared is 16, and 16 times 3 is 48, but times the negative here would be minus 48, mn squared. And then this one would be 4 times 3. That negative that's being squared would be positive, so that's just 12 m squared n. And then this will be negative m cubed. And that would be how you get your answer. All right, now some limits. So the limit as x is approaching 2, it looks like from both left and right, since it didn't give us, so 2 is an asymptote. From the right, it's going to infinity. From the left, it's going down to negative infinity. Well, that means it does not exist. It has to have the same. This one wants you approaching negative 2, which is an asymptote only from the right. Well, that one is just looking at this side right here, which is infinity. This one is approaching negative 1, which is an asymptote from both sides because it doesn't have a symbol. That's negative infinity. This one wants you approaching negative 2 from just the right side, so that would be this. And that y value is 1. So pretty easy to read graphs. Oh, one more graph here. Approach negative 1 from just the right side. So negative 1 from just the right is this way. Not this way, this is left. And I am approaching negative 5. Now, if it didn't have that plus sign, you'd be going to 2 different ones. So that would be a D and E. All right, the limit as x approaches negative 2, you're just going to plug negative 2 in. That's your first rule of limits. Just plug it in. Plug 1 in. Negative 1 plus 4 is 3. But here, looks like I might want to factor. So let's factor. Two numbers multiply to 6, but make 5 is 2 and 3. Those will cancel. You're not left with 0 on the top. You're left with a 1 over x plus 2. And now you plug in negative 3. And you'll get 1 over negative 1, which is just negative 1. This one, you're going to factor the top to be x plus 3x minus 3. The plus 3's cancel. You have negative times the x minus 3. And now you plug in negative 3. So you would get negative 6 times the negative outside, which is 6. This one is approaching 0 from the right. Right means greater than, so I'm just going to plug 0 into the bottom only. Negative 2 times 0 plus 7, it's just 7. This one is just using your intuition about a very large negative number. You only look at this term right here. If you are going to take a very large negative number and raise it to the 5th power, it'll stay negative. But then when you multiply it by the negative on the outside, it will become positive infinity. This one is a fraction going with infinity, so you're going to divide everything you see by the highest degree, which happens to be x squared. And there's a negative on the outside. I should bring that there. This reduces to 1, so negative 1 on top. This reduces to 1, but this goes to 0 because any number over x, when limit is going to infinity, will limit off to 0. So this becomes negative 1 over 1, or just negative 1. This one, notice it's a fraction going to negative 2. So you can plug in negative 2. But it looks like there's an asymptote in this one. You actually have to look at a calculator here. Because I'm looking at this. This would be x plus 2 squared. So So there is an asymptote there. This is an upside down. If you're coming from the left or the right, they both are going to negative infinity. So a little tricky on that one. I'm not quite sure you'll have one like that, but not bad to look at. And then good old derivatives. Differentiate. So again, what you do is you multiply and take away an exponent when it looks like a polynomial. So this derivative would be negative 20x to the fourth. Multiply, take away an exponent. 4x. There's really an x to a 0 power here, and if you multiplied, it would become 0. So this is your answer. Same thing here. Multiply would be 10x. Take away the exponent. Multiply the 1 with the 1/4, you would just get 1/4. X would become 0. And there is, again, a 0 here, and that just be 0 times 1/4 is 0. This is product rule. Product rule says first times derivative of the second plus second times derivative of the first. So first, the derivative of this one is negative 3x squared plus the second, just write the second again, and multiply by the derivative of this. The derivative of that is just negative 9x squared. And I don't think you need to FOIL it out. At least that's what I don't have in my answer key. We're doing the same thing here. First, write out the first. Multiply it by the second's derivative, which is just 6x, plus the whole entire second, write it out, times the derivative of this, which is negative 12x squared. And then this is quotient rule, and quotient rule is, I wrote it right here, denominator, write the entire denominator, times the derivative of the numerator, which is 3x squared, minus the numerator. The derivative of the denominator is 25x to the fourth over the entire denominator squared. Do that one more time. Entire denominator times the derivative of the numerator, which is 0, so this whole thing will go away, minus the numerator times the derivative of the denominator, which is 20x cubed, all over the denominator squared. Best of luck to y'all.